Hi, welcome again. After we have completed confidence interval, I'll skip for now sampling distribution of sample mean and work on the normal distribution, but we'll come back to this section. So, in the normal distribution, you have two questions, and the first one says, suppose we have collected data from a sample and the sample mean is 7. That is the confidence interval. So let's go to the normal distribution. And here we have actually two questions as well. We have the first and the second, and you are supposed to provide your answers here. And that's for the first question. And for the second one, you have to provide underneath here. And you can see on this side, we have notes, which will help you to remember what the functions that we applied in class, especially to calculate the normal probabilities in Excel, and also to calculate X values for a normal distribution in Excel. So here we have the final exam scores in this class. In this class are normally distributed with a mean of 60 and a standard deviation of 5. And so we are required to find the probability that a randomly selected student score more than 65 on the exam. And then we're supposed to find the probability that a randomly selected student scored less than 75, and the 90% of the students score less than what value, and finally 30% of the students scored more than what values. Here is less than, and here more than. Here we have less than, and then we have more than. So I will use example which may look more or less similar, or I will create it to look like this question so you can see how, and you can see how I'm going to work on this example and see if you will be able to answer this question. So this one says a personal computer is used for office work at home, research, communication, personal finances, and so forth. And then suppose the average number of hours a household personal computer is used for entertainment is 2 hours per day. And that is the average that we have. For you, you have 60, and in my case, I have 2 hours per day. Assume the times for entertainment are normally distributed, and the standard deviation for the times is 0.5. This information is important, that we know that the data is normally distributed, and so we can use z-test or t-test if necessary. And so here also it says your data is assumed to be normally distributed, and the standard deviation is 5. For me, the standard deviation is 0.5. So the first question asks you to find the probability that a randomly selected student scored more than 65 on the exam. So let me see if I have the same question. So it says, find the probability that a household personal computer is used for entertainment between 1.8 and 2.75. So let me change this to look like this one here, to find the probability that the randomly selected student score more than 65 on the exam. So in this case, I'm going to say more than 1.8. And then here it says less than 75. In my case, I'm going to say as well less than 2.75, so that I can explain exactly what you have here. In this question, you don't have between, which shows from 1.8 and 2.75. So that's why I had decided to change this question. So I'm going to consider more than 1.8 and less than 2.75. And then here you can see we have 90% of the students score less than what value. And here I may also change, but it says find the maximum number of hours per day that the bottom quartile of households uses a personal computer for entertainment. When we talk of the bottom quartile, that means actually we are looking for the 25%. It's just the wording. So all I'm going to do is to do the calculations, and all we need is to find the probability. And in this case, to find the probability, so all we need is to find the probability such that x variable is greater, or x is greater than, here we are saying 1.8, 1.8, and for you, actually, it is the same, more than 65 on the exam. And here, we are finding the probability such that x is less than 2.75. 2.75. So let me change this. Why is it 18 here? And 1.8. So that's what actually we are looking for. And because here we're talking of the less than, I will add value, let's say the bottom quartile, and I may use the second quartile, which is 50 or 50%. So let me start with to find the probability such that x is greater than 1.8, and for you have is more than 65. So remember, or if you look at the notes here, the provided notes show how to calculate the normal probabilities in Excel. And all you have to do is to use this function, norm.dist function. And it says that this always tells us the area to the left of the value entered for x. To find the area to the right, so this one is the area to the right. So this one is the area to the left. It has to be less than 2.75. But this one is greater than 1.8. It is the area to the right of this value. And so we have to use 1 minus norm.dist. And we provide information which is needed. So we're going to use exactly the same, and then we have to calculate x values for the normal distribution in Excel. And in this case, we will use the norm inverse because we have already probability. In this case, probability is given, which is 90%, and this one is 30%. And so we will need to follow this example, and in this case we will use the norm inverse or norm.inverse, and we put the information that is needed. And also we'll look for the area to the left of the value, which is in my case is 1.8, and 2.75. So look at the notes and see how you can work on your exam. But let me work on this example. So I will use the Excel function. Just put equal sign, type norm, and I'm not going to put S, but all I need to do is to use norm, because we are looking for the probability. Will be norm.dist, but I can actually use norm.dist. And you can see I'm not putting S, which is for the standard distribution. So I'll be required to put X, which is the value. And in this case, we have 1.8, and then you can put comma. That's the value. Let me define that value. So it is probability such that this is greater than a value, which is X. So that's the, this is greater than X. And so the second one also, this is X, but it has to be less than. So I'm going to put equal sign, norm.dist. I'm going to use the function which is for Excel 2007 and earlier. So I'll put X, which is 1.8, and then comma. So I have to put the average, and the average is provided. In this case, it is 2 hours. So I'm going to put 2 there, and then comma, and then I have to put the standard deviation. And the standard deviation is given, which is 0.5. So here 0.5, and then I'll put comma, and I'm supposed to provide a cumulative. So in this case, I will always use cumulative, because the distribution is cumulative. Always I'll use true. That's for the normal distribution. And then I'll close the bracket. But you can see I'm looking for the probability of X such that X is greater than the value. And that is to the right of the data or of the distribution. And so we have to put 1 minus the function, and now you can enter. You will get 0.65. 0.6554422. You can bring this to 2 decimal points, which will be 0.66. Then for the second one, I'll put equal sign, and because it is less than, so I'll just use the norms, just norm.dist to find the probability. And so I'll put the value, which is 2.75, comma, and the mean, which is 2 hours, and then comma, and standard deviation, which is given here, is 0.5, and then comma, and we have true, it is cumulative, and then close the bracket. You can see because it is less than a value, it is to the left of the value, so I won't put 1 minus here. So just enter, and I have 0.933193, or 0.93 if I consider 2 decimal points. So let me see how you're going to work on this too. And here we have 90% of the students score less than what value. So actually this is the opposite, and here we're talking about less than what particular value. And so in this case, all we have to look for is we already have the probability and the notes are provided. So we have probability. This should be greater or less than the value. So you get the probability, and the probability is actually provided. But we are going to use the formula, which is norm inverse. And the same, we will consider the area to the left. Okay, so here, here we have 25% greater than, let's say greater than 25% and 50% less than. I'm just creating those values, which will look like what you guys have here. So it will be greater than 25 and less than 50. So I'll use Excel function, just put equal sign and type norms, norm inverse. So I'll just use norm inverse, and all I have to do is to put the probability, which is 25%, and then the average will be the 2, and standard deviation will be 0.5, and then that's all, and I have to close the bracket. And here we're talking about greater than, so we need to find the value. So I'm going to enter, and the value will be 1.662755. And so here we'll do the same, norm dist, and it will do exactly the same. So we have x, sorry, not norm dist, but norm inverse. And so we have to put probability, which is 50%. Then the average is 2. Standard deviation, put the comma sign, standard deviation is 0.5. And so you can close the bracket and enter. So we have 2. That's all with this question number 1. And let me see how do you work on this second question.